Hi champ, how are you doing? I hope that you are good, healthy. Champ, welcome into the another amazing class. I'm your master teacher Shivam Gupta, and in today's class, we're going to talk about the cubic polynomial. So let us start, champ. So in this class, we will learn that what is the general form of cubic polynomial, what are the zeros, how to find the equation of the cubic polynomial from its zeros, and the most important thing, the relationship between the coefficient term and its zeros. So let us start with the general form. So as we know that, champ, the cubic polynomial is 3-degree polynomial. So my general form will have the degree 3, ax cube plus bx square plus cx plus d. But the must condition is what? The coefficient of x cube cannot be 0. If a is 0, then there will be no term of x cube and my degree won't be equal to 3. So this won't be equal to my cubic polynomial. That is why my a cannot be 0, and whereas all the other constant a, b, c, d are real numbers. Okay, now let's see what are the zeros of a cubic polynomial. So let's say, champ, we have a cubic polynomial. So it's very obvious that we will be having 3 zeros. So now let's say x equal to alpha, x equal to beta, and x equal to gamma are the zero of the cubic polynomial. So with the help of the factor theorem, we can say that if x equal to alpha is a 0, then x minus alpha will be a factor. Same, if x equal to beta, x equal to gamma are the zeros of the cubic polynomial, then we can say with the help of factor theorem that x minus beta and x minus gamma will be the factor of the same cubic polynomial. So now we can write the cubic polynomial as the product of its factor, right? Just like we write the number 6 as the product of its factors 2 into 3. In the same way, here we can write the polynomial as the product of its factor x minus alpha, x minus beta into x minus gamma. After that, simply multiply all the brackets and simply take the coefficients of x cube, x square, x and constant separately. Now, champ, we have one equation, the cubic polynomial, right, in the form of its zeros. So, champ, what do you think? Can we find the cubic polynomial equation from its zeros? If I have given you 3 zeros of a cubic polynomial, can you give me the equation of that polynomial? Yes, and how to do it? Let me show you how. So, champ, the equation which we have derived, okay, just try to look at this equation. In this equation, there is no a, b, c. There are only alpha, beta and gamma. And alpha, beta and gamma are nothing but the zeros of the cubic polynomial. So that means what? If I know the zeros of the cubic polynomial, I can find the cubic polynomial equation, right? How to do it? Simply, this is alpha plus beta plus gamma. I have to add all the zeros. Alpha, beta, beta, gamma, gamma, alpha. We can put the values minus alpha, beta, gamma, the product of the zeros. Very easy, right? So now, champ, let's say we have to find a polynomial whose zeros are minus 1, 2 and 3. So, champ, first of all, we can say that alpha equal to minus 1, beta equal to 2, gamma equal to 3. We know the equation. We know the equation. Simply put the value of alpha, beta, gamma over here. When you will put the value of alpha, beta, gamma over here, by magic, you will find the cubic polynomial equation. It's so easy. Okay. Clear? Excellent. Very good. Okay. So now, champ, let's see the relationship between the zeros and the coefficients of a cubic polynomial. So, champ, in the last, we have find out this equation where we can find the cubic polynomial equation with the help of its zeros. But we can also write the cubic polynomial equation in the general form, right? We know the general form of the cubic polynomial. Now again the same thing. In order to find out the relationship between the zeros and the coefficient, we will compare these two equations. That's it. Now in order to compare, we know that the coefficient of x cube will be same. Only the coefficient of x cube will be same, then only I can compare, right? So what I will do, I will divide by a both the sides. Now I have divided by a both the sides in order to make the coefficient of x cube same. So I got this equation. Now it's very easy. Now simply compare x square coefficient, x coefficient, constant. You will get three relation between the zeros and the coefficient of a cubic polynomial. So my first one will be what? When I will compare the x square coefficient minus alpha plus beta plus gamma will be equal to b upon a. I can take this minus sign to the other side and this will become alpha plus beta plus gamma equal to minus b upon a very important result. When I will compare the coefficient of x, right, I will get what? Alpha beta, beta gamma, gamma alpha equal to c upon a. And in the last, when I will compare these two constants, minus alpha beta gamma equal to d upon a, and hence I can write alpha beta gamma equal to minus d upon a. I hope it is clear. Excellent, very good. Champ, these are the three relations which are very important, and many times the question are asked directly based on these results. Okay, so look at this one now. Let's verify the relationship using one example. So champ, find the zeros of this cubic polynomial and verify the relationship between the zeros and its coefficient. So first of all, in order to find the zero of a cubic polynomial, we have to use the hit and trial method. Okay, we have to use the hit and trial. Otherwise, simple factorization. So by doing hit and trial, for x equal to 1, I checked the value of this cubic polynomial. At x equal to 1, the value of this polynomial is coming out to be 0. Same, at x equal to 2, at x equal to 3, the value of this polynomial is coming out to be 0. If the value of polynomial is 0, this means we can say that x equal to 1, x equal to 2 and x equal to 3 are the zeros of the polynomial. Right, champ? Very good. If these are the zeros, 1, 2, 3 are the zeros, so we can write in the factor form. Right, champ? Or simple, you can do the factorization also. So now, I have the zeros. Now let's check the relation. So I have find the value of a, b, c, d by simple comparing with the general form. Now I know the results directly. Alpha plus beta plus gamma is what? 1 plus 2 plus 3. Minus b upon a value is what? 6. Both are same, right? Both are same, which we can see from the direct result also. Alpha plus beta plus gamma equal to minus b upon a. Same here. Alpha beta, beta gamma, gamma alpha. I have put the value of alpha beta gamma in this. Separately, I have find the value of c upon a also. Both values are coming to be equal. In the last, alpha beta gamma, simply put the value of alpha beta gamma. Separately, find the value of minus d upon a. Both are coming out to be equal. That means the results which we have proved are perfectly fine, right? And getting verified over here also. Very good. Excellent, champ. So now, champ, let's see one more example. Look at this example. Okay. And if the zeros are given, alpha is not given, we have to find the value of alpha and b and d. So, champ, first of all, we know the a and c. We only know a and c, right? And we know two zeros, one is unknown. So, champ, with the help of a and c, what we can find? Alpha beta, beta gamma, gamma alpha equal to 2. From here, I can find the value of alpha. And as soon as I got the value of alpha, alpha beta gamma equal to minus d upon a, I got the value of d, right? Alpha plus beta plus gamma equal to minus b upon a, I got the value of b. That's it. That's how easy it is. Okay, I hope it is clear. Okay, champ, so let's summarize our class. Champ, first of all, in this class, we have seen the general form of a cubic polynomial where a cannot be 0. If the zeros of the polynomial is given to me, I have to find the equation of cubic polynomial. We can simply use this equation, and we have seen also how to derive this. Okay, derivation is very important. After that, a very important results. Okay, alpha plus beta plus gamma equal to minus b upon a. Alpha beta plus beta gamma plus gamma alpha equal to c upon a. Alpha beta gamma equal to minus d upon a. Always remember. Okay. So, champ, that is all for this class. I hope you enjoy. Take care.